Hello everyone, welcome to today's video. In today's video, we will talk about two specific techniques and which are always found in JEE mains and JEE advanced examinations. And these are for integrations. And we will talk about two special functions basically and how to use them to solve a lot of problems, which you can solve them in under a minute and under 20 seconds if you have good practice. So I'm going to show you that. So it's not usually taught in any school course, and you may not find it in a lot of books. Even if you do, they will not really explain how this actually works because, well, it is beyond the syllabus of JEE, right? So the function is called beta function. It is very closely related to the gamma function, and you can see the gamma function video on the top right. You can check it out how gamma function is and how is it defined, how is it useful. So first, let's go over a little bit of details on beta function. Then we will do a JEE Advanced and JEE Main PYQ to understand how to use it and how to get results in under just 20 to 30 seconds max. This is the integral definition of beta function. So beta of AB is basically 0 to 1 x to the power a minus 1 whole into 1 minus x whole to the power b minus 1 dx. And let's consider a and b are natural numbers, that is integers from 1 and all the way up to infinity, correct? So whenever you see this kind of a form, a definite integral with limit 0 to 1, and you have x to the power something and 1 minus x whole to the power something, this is the form of a beta function. Of course, there are other formats, but you should not be requiring those right now. If this is the thing, you can prove that beta of AB simply equals gamma of A into gamma of B by gamma of A plus B, where gamma AB is as follows. Okay. What we can do from here is we need to understand the few basic gamma values. So I'll just recap that gamma of 1 is 1 and gamma can be defined recursively as gamma of 1 plus n, which is n into gamma n, and gamma of half is root pi. So that is all you need to know. You do not need to know other than this stuff. Okay. Few examples of beta function. So let's say you have an integral 0 to 1 x cube whole into 1 minus x whole to the power 20. Express the powers in forms of beta functions. So if you remember, the beta function has a minus 1 and b minus 1 in the exponents. And the answer is in terms of gamma a, gamma b, right? So here 3 is nothing, not 3, but it's like 4 minus 1. That is why we have a gamma. Similarly, 20 is gamma 21. And in the denominator, you simply have gamma of a plus b, which is gamma 25. Remember that gamma of n is n minus 1 factorial. For example, gamma of 100 should be 99 factorial, like that. So you can simply put the values and get the answer directly. You do not even need to calculate this integral. Any integral of this form. Again, 0 to 1, 1 minus x square whole to the power 4 dx. Similar format, 0 to 1, and you have the same thing like 1 minus x, but not really 1 minus x, right? It's x square. What you can do is you can take u equals to x square and transform it into a gamma beta integral, which is half into 0 to 1 integral, same thing. Here you again express it in form of a beta function, right? Half minus 1 and then again 5 minus 1. So it will simply give you this value. You can calculate the value to get 128 by 315. Let's look at the JEE problem. So let's say this is a JEE problem, right? The problem was from JEE in 2024, 8th April morning shift, and you simply have this integral which has 147 I-20 equals to 148 I-21. Now, you simply understand that we need that one I-21 by I-20 value. We simply need IN plus 1 by IN, nothing more. So again, the same substitution of u equals to x to the power k, this would get you basically dx equals to 1 by k and all this stuff, right? Put this in and you will get a beta function. Since it is given that I-21 divided by I-20 is 147 by 148, we can again conclude that, okay, so since this is the value of ik for any in for any value of n, and there is a 1 by k which is common to this, when you actually find out I-21 by I-20, the 1 by k is cut off and you simply have a bunch of gamma functions and their values regarding k. If we simplify this easily by writing gamma 22 as 21 factorial, gamma 21 as 20 factorial, cutting off the gamma 1 by k, and then again writing gamma 22 plus 1 by k, this term here, as gamma of 1 plus 21 plus 1 by k. You remember the recursive formula gamma 1 plus n gamma n, right? So you simply get this value just maybe within 15 to 20 seconds if you have enough practice with the beta function. And this is nothing but equal to this 147 by 148. Solving it, you easily get the value k equals to 7. You do not even need to waste a lot of time for doing this. Of course, this can be done in other ways, but once you know the method, you are already sure of what to do. This way, you do not even have to think further. Okay, this was another example from the 5th April evening shift, and it was kind of the same. They actually have given you the beta function here. They're not defining it by name. This is the beta function, right? And again, integral of the same kind, and they're asking you, okay, what is the value of this integral? You know the deal. You have to do e equals to x to the power 10, transform it into a beta integral, and you simply get 1 by 10, beta of 1 by 10, comma 21. Find out the value, and it's 2120. And it's very easy with the beta function. Okay, all this stuff you will get basically in the description. There would be a PDF of all this material that I'm using. Okay. Next, we have GIF and fractional parts. So the greatest integer function is simply defined like this. You can go through this. You already might know this. Box of 1.2 is 1. Box of 2.5 is 2. Box of minus 3.1 is minus 4. This is important because greatest integer function basically gives you the greatest integer less than number. So you cannot have minus 3 as the answer because minus 3 is greater than minus 3.1. That is why in negative cases you have the lesser number, minus 4. And fractional part is nothing but defined as x minus box of x or x minus GIF of x. So it's basically, as you can see the examples here, it's all like this. Always use the definition, okay? And we'll just do one problem here, but this is again something which repeatedly keeps coming on JEE exams, like 0 to 1, 1 by 7 to the power 1 by x of box of 1 by x, right? Whenever you have a function with box and you see that the function inside the box is not really in its simplest terms, try to always bring it in the form of box of x simply. So whatever is inside the box, try to substitute it off with a new variable. So here we have y equals to 1 by x. Do all the limits, you will simply get this integral right here. Okay. Now, whenever you have now the limits 1 to infinity, remember that the box function gives you the greatest integer less than the function. So if the interval is 1 to 2, the box of y will become 1. If the interval is, let's say, 2 to 3, it will become 2, and then k to k plus 1, it should become simply k. So as you can see, I can write this integral from 1 to infinity as a infinitely many sum of integrals from 1 to 2, 2 to 3, 3 to 4. In terms of summation, I can simply write summation k equals to 1 to infinity k to k plus 1. This is again easy, and this is a telescoping series. You should do it yourself. But the point is, there are so many kinds of things in each and every kind of these problems, like integration, derivative differentiation, algebra, complex numbers, matrices, the Cayley-Hamilton theorem, and stuff like that. And you should be able to, you should learn all of this before attempting, because that is going to save you a lot of time and probably get you very close to get a perfect score in maths in JEE Mains. So that would be it for this video. Check the description, and also if you want to join the calculus crash course, so let me know in the comment section. That would be starting from the Monday, and also the telescoping series is also covered there. Anyway, so thank you for the video, and I'll see you in the next one.